Okay, so it's muted. So I want to talk about, well, the agenda for today. Talk about midterm, help you with the preparation, and also I want to mention, before that I want to mention something about the group of your final project. So has everyone have a group already? Okay, I need. Okay, battery is running low. Wait, one moment.
Do we need to sign?
What's the question? Who's
Do we
asking?
need to sign
Sign what?
for group members?
No, I want you to freely form your group. And if somebody cannot find a group. Okay, so what I do today is open up a Dropbox. So everyone who already have a group, please let one of your, this is for both online and in-class student. If you already have a group, please have one of your group members send the list. No, not send me the email. Upload the list of your group, a list of group members to the D2L. I only need one copy for every group. And for those who do not have a group yet, please just upload the documentation there said you do not have a group yet. Okay? Then from there I will know how to set up all your groups and through the D2L. Alright? And the first group assignment is due October 7th. Yeah. I think the CRC card, which is kind of a design of your system. So well, we still have plenty of time for that. Well, let's finish the whole group thing by the end of this week so that we can work on those things. Work on that CRC card, which is a very short assignment. Okay. And for your information, the CRC card thing is not in the midterm, so don't worry about that for the midterm. Right. But for the midterm, what are we gonna have is what the midterm looks like. Okay, we will have like problem description, like what kind of system I want you to design. Okay, it could be okay, the vending machine, something like that, those kind of system. Okay, because I mentioned vending machine, it won't be a vending machine, but it will be something pretty similar to a vending machine, something like that. You model that system, okay, with those classes, okay, those relations, okay. But the first thing, if you still remember what we do with that refrigerator, okay, we will have something similar to that. We create an abstract data type through that. Okay, so I think I have graded all your assignments and provide you with some feedback. So please go back and read your feedback if you haven't. Okay, right. It's gonna be something like to model an abstract data type for that. For example, vending machine. That is for water dispenser, ice dispenser. Okay, that's an ice dispenser. So we want to identify. Yeah, one of the things a lot of you are missing in the ADT is, okay, you directly jump into this operations, but you forget there's another part. We mentioned there's three of them, right? One is the data, second is the relations of those data, and then what is the operations to change those data, doing something to those data. Okay, so you need, in the definition of an ADT, you need to mention what is the data, or what are the different types of data, and then you mention what's the relations between this data. Okay, like let's go back to see it a little bit. Week 3, is that week 3? Week 2. Yeah. Stack. That's operations. But before operations, see, when we're trying to describe our stack ADT, we first have a definition. Remember, don't forget this part. Yeah, that's the only problem. That's the only big problem there I saw. But I think if you read my feedback, you won't, or you listen to me at this moment, you won't forget this. Just keep in mind the definition. Don't forget this. And I know all of you are pretty did a lot of efforts defining all these operations. Okay, so but don't forget the definitions. Operations, of course, it's important. It's a key. It's the core of this ADT. But definition is also important. It gives a lot more information, like 2 informations there, while operations only define that 3rd information. And when you are trying to define the operations, just leave some comments of what it does, what this operation does, and pre or post conditions if you think there is any. Sometimes there's no preconditions, right? So if you think there's any precondition, post conditions, just put it there, okay? Because well, everyone will have different kinds of design. So there's no standard answer that this has a precondition like that. Maybe you implement it in another way. So well, it's going to be evaluated case by case. Sometimes there's no preconditions there, it's fine. Sometimes I think there should be some preconditions. Alright, but if you think there's something there, put it there. Or if you have any assumptions that you think the problem description is not so clear about, then you make your own assumptions there. Write it down. Then we can have that evaluated. Okay, so that's about ADT. And abstract data type, just want you to have more. Yeah, this is where we provide this information. We were giving this information here, a description of the elements, composite data, and a description of the relations between the individual components in the data type. Okay, I know we won't have a description of the data itself. If you see definition and operations, if you do not specify the constructors there, it's fine. So first, you will read a whole page of problem description, which is the description of what we want, kind of the requirements, like what kind of system, what the system does. Okay. And then we will have some ADT for sure. You need to build some ADT. And also the modeling. Yeah, that's okay. Just 2 assignments, ADT and modeling, right? So the modeling, go back and read the feedback I gave you. Okay. All right. The modeling, what we want to do there is the class diagram. Yes, a class diagram similar to the vehicle system. So I'm gonna ask you to do some certain kinds of I want to see the inheritance, aggregations, has those relations. Yeah, it's going to be similar, very similar to the modeling homework. Okay, if you still have questions in modeling homework, I think I provide all this feedback with enough information. But if you still have them, email me before the midterm. I will try my best to answer all of your emails. Okay. Yep. yeah, and also one instance. If you remember, we have an instance. So to describe that instance, it's actually you describe that object, which is that instance created from one class. Okay, maybe your car, my Honda. Okay, my Honda. Okay, so but I want to clearly see what attributes are there and what methods are there, because we have a whole bunch of level of inheritance, generalization, inheritance. Okay, generalization. Therefore, we need, because a lot of attributes, they are inherited not directly from that class up above it, maybe class at some level above it. Okay, so in order to make it more clear, I want you to describe that clearly, explicitly. You just tell me, okay, in this Honda, in this my Honda object, it has plate, type, something, color, okay, and all those operations, something like that, so that we know that you understand. You can inherit all these attributes method from everything above you. Okay. Yeah. That's instance. Yes. So, well, this I'll give you a very clear instructions in what should be included in the modeling. Okay, but pretty similar to the homework. Generalizations, aggregations. So it requires you to understand what are those. I believe you all understand that, right? Because I see no problem in understanding of this concept in your homework. Just some details you may be missing. You want to improve, okay? And then that's design. As I mentioned, it's gonna be open note. We don't have like concept for you to memorize to get the points. Everything is based on your understanding to whatever we have learned, right? All right. The second thing is, if you remember that the first day of the class, not first day, the first chapter of the modeling, how we create a great program, right? There's 3 steps. Let me record that. Have you record that? First step is we do whatever the customers want the program to do. Second is we kind of follow the principles of the object-oriented design. The third is we build for extendable program, something like that. So that's how we optimize the guitar shop. When we're trying to optimize the guitar shop, we do all these 3 steps, right? Okay, so that's optimization to the guitar shop. So in the midterm, we will have an optimization to another system. It's separated from the last problem description, from the ADT modeling. Okay, that's one part. Part 1. Part 2 is I'm gonna give you some sort of already designed system that I may need you to like optimize that a little bit. So in order to do that, what you need to understand is this is chapter 1 thing. Well-designed software. Okay, So go back and read the book to see what do we do in each step. Right? First step is it returns a list. It needs to return a list, and there's a bug there. Like you have to match the lowercase, the uppercase. It's case sensitive. We don't want that, and we want to return a list. So we go back and modify that. And second thing is really important. The second step is we're trying to do something called a delegation, which means we want the principle here. We want the object class to do whatever it is supposed to do. If you think there's something, some functionality that shouldn't belong to this class, maybe you need an additional class to include that. And you delegate that to that class whenever you do that. Like the guitar, we are trying to use the guitar, create the guitar object for the search. But the guitar object is supposed to be a guitar, right? Why do you do, the guitar shouldn't have functionality called search, right? So instead, we need to use the guitar specification class for that search, right? Record that part, yeah. So that's we kind of follow the principles. And then in the third step, we can tell the benefit of doing such kind of modification, right? So later on, when we're trying to add a new type of guitar, okay, we just need to modify that guitar specification class instead of touching all of them. So whenever you want to do some modification, change to a program, you want to limit it. You want to limit the class you need to touch. Yeah, the less class you touch, the less possible you're gonna make those mistakes. So you want to kind of restrict that part, and yeah, try to go back and read the book, the chapter 1. Understand why we are when we follow the object-oriented design principles. When we're following that, why does it make the extend so easy? Okay, but you need to really understand that part, and then we can apply this knowledge to the midterm exam, that question which asks you to optimize your optimize the software, the design, optimize the design. Yeah, and I'm gonna give you a class diagram which is already, so no code is required, no coding is required. Okay, you are not going to write pseudocode or something, but just the design of the class diagram, the structure, the relations you define. Okay, then maybe you have for example, the guitar shop, I have the original design there, but just as a class diagram. Then I'm gonna ask you, okay, if I'm gonna to do a lot of change in the future on adding different types of guitar, or maybe a lot more innovation in guitar is happening in the maybe strings or something like that. Okay, I'm gonna tell you this may need a lot of change. Then with that in mind, I'm gonna ask you, how can you optimize the design of the system? Like based on that old class diagram, you give me a new class diagram, like guitar specification. Okay, I'm gonna have a new class called guitar specification, and guitar specification, and the guitar is gonna be aggregation relations there. Okay, yeah, you need to remember how do we draw the aggregation relations there, how do we do the generalization relations. That's the notation. I mean the notation there. What's a diamond, and the arrow. Generalization is the arrow, and the diamond sign is the aggregation. Okay, so don't forget that. Oh yeah, it's open node, so you can check. Yeah, that's fine. But yeah, keep that in mind. Don't forget that. You need to explicitly tell me which one is aggregation, which one is generalization, and which one maybe there's something that do not have any of these relations. They're just two classes which are collaborating or delegation, something like that. All right. So yeah, delegation usually has a relation there. All right. So it shouldn't be very hard. My phone? No, it's not my phone. Okay, shouldn't be very hard. Well, the use cases won't be included in the midterm. The CRC is not in the midterm. Midterm is all about those three things: ADT, modeling, and the optimization. Okay, so I want you to have an understanding of those three things. And it's not difficult at all, given the time, given the open node condition. So yeah, so rely on your understanding. Yeah. And from your homework, I think you all have a good understanding to those concepts. Yeah. So I won't worry about that. Yeah. Okay, questions?
I don't quite understand what delegation is. I understand.
Delegation. Okay, usually you can understand it as like has a relation, has a, because delegation is something like when we are introducing the delegation, it's like we have a guitar class there, but some part of the guitar class, it seems like it shouldn't belong to that, but we are using that somehow in this class, like those specifications. Okay. We're using, of course, we need in the guitar class, we need the model, the price, the name, the wood, the materials, all those information are needed. But when we are trying to search for the guitar, it doesn't make sense to create a guitar to search for a guitar. So that means we need some change there. Therefore, we put the guitar specification class, and we dump all the information there, and we delegate that function to the guitar specification. That's kind of like, and also the relation between this guitar and guitar specification has a relationship. Okay, like human. Okay, like a student class has a record, has a grade record. Okay, which indicate A, B, C, or whatever grades you make in the university. Okay, but it may be a design decision that I want to separate this as a grade information class, but this student class has a grade information class. Okay, has a relation between student class and grades information class. Okay, and then when we're doing something like functionalities in the grade, it's sort of like a delegation. Okay, so to be simple, you can think it as aggregation. This delegation, you can think it as has a relation as well. Yeah. Yes. Right. Any other questions? Just ask. Yeah. So that's so clear, so easy.
For delegation, you give us example. The example or simple.
Just delegation. Just that guitar. the guitar delegation, right? We're not doing the specification of the information in the guitar class itself. Instead, we're doing that we delegate that functions to the guitar specification class. And the guitar class actually owns or has a relation between the guitar and the guitar specification. Delegation means well, we gave you a real world example, like maybe I'm using a calculator to calculate something, right? Maybe I can do the calculation by myself, or later on I decide, okay, the calculation functions, maybe it needs a lot of changes. So before that, I do the calculation, like 1 plus 1 equals 2. I can do that in this object, in me, in this class. Okay. Later on, I think, okay, this calculation will maybe more efficient if we use a different implementation. Maybe not I calculate in my brain, in my heart. Maybe I can use a calculator. We use the electronic thing to help us with more efficient calculation. So I'm not going to implement that calculation in this class. Instead, I'm going to have a separate class for the calculation, and whatever change to the calculation is evolved in the computer. We have a core i7, i5, i7, blah blah blah. It's keep evolving, but it's none of my business. Alright? So I'm still here, I'm a person, class, nothing happens that when they are evolving that calculation thing. But when I was doing this calculation task, there's a delegation. It's a delegation. So I'm gonna I'm gonna ask so somebody want me to calculate 2 plus 4. Okay, so I'm not doing that. Instead delegate that task to a delegation class, calculator or computer, something like that. Maybe the implementation of the delegator of the calculator is a small calculator, or it's a computer, or it's a supercomputer, whatever that is. But I don't care. Me and the calculator, we are in the has a relation. I have a computer. I have a calculator. Calculator can be a computer, can be a supercomputer, whatever. But I have that. So when I have a task, I can give the task to the calculator. Okay. So that's an example. Right. Just that part is separated. Okay. And the person class is not supposed to do the calculation. Right? Because person is not, although person, human, can do the calculation, yes. But we're not designed for that purpose. Okay, what's the purpose? We are standing here. That's another problem. Okay, so why human exists? That's another problem, another level. All right, but definitely we're not only created for doing the calculation. Okay, but the calculator is. So we separate that class called calculator. We have a delegation. And usually it's a has a relation, right? I have that calculator part, yeah, or yeah, something like that. Yes. Other questions there? And the guitar and guitar specification. That's a really good example. So go back and read that. Have a good understanding of that. So a very key feature there is when we apply the object-oriented principle as a second step, then at the third step we see the benefits there. So why this principle leads to the benefits, you need to understand those. Okay? Because the outcome is when we apply these principles, when we're changing this code and we were doing some modification, we add some requirements, we just need to attach that one class. Right? That's the kind of outcome. But you need to have the ability to understand the code. Yeah, you can remember this concept. Yeah, when we can restrict it the coupling. We have loose coupling. Okay, when we want to do some change, we only need to do it in one class. But why? You need to understand the code, right? But we are not writing code in the exam. But the code in the textbook, read it, so that you can understand why when we have an extra class, why that extra class help us with the later change to the system. Okay, that's just a 2 or 3 page. That code is several lines, just 2 or 3 page. Try to understand that part. Okay. Yeah. Yes.
I kind of understand that point, but the thing that messed me up was on the code, the match function. That's the only line that I have a problem with.
Match function.
Yeah, on the book.
Yeah. Okay, let me pour out the book.
Page 45.
Okay, let me know which page so that I can directly jump to the page.
45. So under the inventory, Java, like we have the guitar that gets
Wait, inventory.java. Okay, here. Yes, okay, this part, right?
Yeah.
This part. Okay, so if you look at the old code, the original code, original code is, instead of guitar specification dot matches, okay, instead of this, we do all the comparison in this inventory class, right? We compare every attribute here, right? So, but here when we have a specification guitar specification class there, we define a match class which did very similar functionality of this comparison, right? But instead of doing comparison in inventory, we let the specification class do the comparison. So that's kind of following the principle of we want the object to do its own job. So the inventory is not supposed to do, inventory is going to take care of the inventory, what I have. We take care of that, we manage that. But to match, to compare, that is not supposed to be something the inventory should do. That's something the specification should do. Okay, it makes more sense to let the specification class to do the comparison. So here we kind of move this comparison from the inventory to the match, to the guitar specification class. Okay, then here instead of getting all the using all those comparison, writing all those comparison here, we do the comparison in the guitar specification class here. See, Boolean matches. This is actually a function in the guitar specification class instead of inventory class. All right. So that the benefit of doing this is, yeah, we know, like when we add some new attributes to the guitar, like the 12 string, something like that. When we add that new attribute, number of strings, when we add new attributes to guitar, we just need to do that in the guitar specification, okay? Because no other class has that information, and you are using that information. So we just need to do that in the guitar specification class. And also, when we are adding some new attributes, it will result in the change in the comparison, because we have one more attribute to compare when we're trying to do the search, right? So instead of doing that compare in the search method, we just delegate that comparison functionality to the guitar specification class. Okay, so you do all the change in one class. We add the attributes to this guitar specification class, and then we change the match function within that guitar specification class. So everything happened within that class. That makes the change so much easier. So here you just need to add one more line to compare the number of strings here. See, if number of strings, the specification number of strings doesn't equal to return false, right? So you can add this one. You can add this this statement into this search, but logically it doesn't make sense. When it match, when this makes sense, when this change makes sense in the logic, okay, it's less. It's well, it's less likely you make more mistake, right? 'Cause you know, okay, yeah, if I'm gonna add the guitar specification one attributes, then the comparison needs one more comparison. So everything of them happen within this guitar specification, yes. So I just need to modify the guitar specification class. But if you have a design that doesn't make a lot of sense, like you have everything in the inventory, later on when you want to do the change, okay, you totally forget what is your design. Maybe it's more convenient you dump everything into one class, but later on you cannot locate, okay, how can I make this functionality implemented? Where should I find this? Where should I find all this functionality? Right. So it, well, when we're doing this kind of OO, following the OO principles, well, those designs also follows match nature logic, right? So it makes sense. So when we are trying to fix a car, for example, if the tire has a problem, we fix the tire. Okay, if the tire has problem and the part of the tire is in the engine, we need to fix the engine as well. So that gives you a huge problem. Okay, but in reality, the tire has problem, we only need to fix the tire. That makes sense. Because you cannot put part of the tire into the engine, right? But in this implementation, in the object-oriented design, in the software, it's all up to the designer, to the programmer. Some programmer may put part of the tire functionality into the engine. That happens, that's a bad design. So when you want to change to fix the tire, you need to, you don't know, you have no idea that maybe later on you have no idea why should I put this tire code in the engine, right? So this is part of that. You put the match code in the search. Okay, but because of the engine is driving this, is the power driving the tire. So you think I need to put part of the tire information in the engine. Okay, maybe when you are running the engine, you are considering the size of the tire so that you can configure the output of the engine, the output of the power of the engine. Sometimes you do that, okay, then that brings a problem. Here is we fix this problem by putting these things to where it should be. Okay, you don't, when you want to change a tire to a new type, you don't want to change the engine. here's the thing. When you are going to change the guitar specification, like adding a new attributes, you don't want to touch the inventory, right? So if you want to decorate your tire by some lights there, you don't touch the engine here. If you have a new 12-string guitar added, you don't touch the inventory. That's the same idea behind. Okay. Yep. Any other questions? Other questions? It's all clear? That's great. Yeah, that means I'm doing a good job.
Yes.
Yeah. Alright, so if everything is clear, I'm gonna let you to maybe prepare for the exam for the rest of the class. Alright?
Okay.
Alright, thank you very much. And for online student and all of you, if you have any questions, you want clarification, yeah, send me email before the exam. Okay. Alright, thank you so much.